I'm back, and we're gonna do this problem with a marble launcher. Yay! So a marble launcher that launches marbles. It's pretty cool. At a fixed initial velocity (VO) situated at a distance x away from the wall, the angle of the marble launcher can be varied, and let theta be the angle at which the marble hits the wall at the maximum possible height. What is tan theta? So basically, what it's saying is like, given these conditions, given that we want to find an equation, so like we can plug the variables in and then see what angle we should shoot it at, um, to get the max height, right? So like, let's say it's like 20 meters away, and our initial velocity is like 20 meters a second. Then what angle should we shoot it at in order to get the max height? That's the entire point of this problem, right? Just given these conditions, what angle should we shoot it at? No, if the I don't know if there's a man 30 meters away and your bullet can only be shot at 20 meters a second, what angle should you shoot your gun to hit the man? And that's pretty violent. Why would you shoot a man? Oh, maybe you're like police officer, right? Don't police officers like shoot guns to kill people? Like if it's necessary? Yeah, yeah. Oh wait, no, that's kind of a bad example. Because it has to be like the height. So it's like, let's say the man is 30 meters away and you don't want to shoot him at all. You actually want to get the highest height above him so you don't hit him. So what angle should you shoot it at? So let's just get into the problem. So this is where the y of x equation comes back in. X tan theta minus g x squared all over 2 VO squared cos cos square theta. Okay, so this equation is basically describing y as a function of x, the height as a function of x. So it gets rid of any time. And how we derive this, I think I derived it in one of my videos. You can probably look back at that, but you just do like t equals to like x over like VO cos theta, and then you just plug it into y equals to V O t minus 1/2 GT squared, and you just plug it in. And that's how you get the formula. So yeah, I would recommend like memorizing it because like it's really useful. Like I've used it like 3 times throughout the entire series. It's a lot. So yeah, basically what we want to do is we want to find the maximum height. And basically now the question becomes, given this parabola, how do we find the maximum from it? How do we find a maximum in general? A maximum on a graph occurs when the rate of change equals to 0. Um, yeah, it occurs when the rate of change equals to 0. And that also goes for the minimum too. So basically what we're going to do is we're going to apply calculus. Yay! Yeah, so in order to find the maximum, we need to find a place where the rate of change equals to 0. And where that happens is where the derivative equals to 0. The derivative of the function equals to 0. So basically what we're going to do is we're going to take this function, we're going to take the derivative with respect to theta. And why theta instead of x? Well, one, x will be constant, and two is that theta is a thing we're changing. That's why we're going to take the derivative of that, right? It's changing. That's the thing that we want to find. So yeah, this will be pretty annoying for me because honestly, I have not done calculus in a long time. Well, like not like calculus, like I've done calculus before, but like it's like the actually I did like a couple of videos ago, but like this like actual like real like differentiation, not done in a long time. Okay, so first thing to note here, this one was pretty the derivative of the sum is the sum of the derivative, where this yeah, the derivative of the sum, this is technically a sum. You can do like plus minus this. So the derivative of the sum is the sum of the derivative. So for this one, x is a constant, so you take it out of the derivative. And what's the derivative of tan theta? It's going to be secant squared theta. And for this, g is a constant, g is gravity. X is a constant, 2 is a constant, VO is a constant. And that leaves us with this term, cosine negative 2 theta, right? Because you can just put it like that and have the negative exponent. So this is the only other thing we need to differentiate. Oh my God. So yeah, negative 2 cosine. I should probably make this more clear actually. We're gonna rewrite it like this so it looks clear because now it actually looks like a place where we'd use a chain rule. Cos theta, and so that's the outer times the inner. The inner is gonna be negative sine theta. Oh shoot, and I forgot when you put it here you have to negative 3. Here, like I'm just gonna redo that entire thing, sorry. So yeah, yeah, remember the power rule, right? When you put it here, it's gonna be n x and then n minus 1. That's the rule. So cosine negative 3 theta times the inner, which is going to be negative sine theta. Cool trick is that anything that starts with a c, if you're taking derivative of it, the derivative of anything that starts with a c, like cosecant or cotangent, it will always be negative. I don't know how that works out, but it does. I learned this from Black Pen, Red Pen. I think that's his name. He's like, y'all should check him out if you need like calculus help, especially if you haven't taken. I haven't taken it yet, but I self-studied it to do this. Yeah, it's pretty cool. Um, See, you can't let the school like limit you. Even though you're not taking calculus, you can still learn it by yourself. If you're just that determined, you're gonna need to want it that badly. You know what I'm saying? Yeah. So that's gonna be our derivative, and we're going to multiply it by this, whatever term that is, lot gx squared all over 2v0 squared. Cancel, cancel, gx squared. We're gonna do sine theta all over cos theta, and that equals to gx squared, and sine over cosine is just tan theta. Tan theta, and you're gonna do cosine squared theta. Yeah, and this is gonna be our final term for the entire thing of that. So yeah, I'm just gonna move it here, and I'm gonna take this boy. This boy. Oh, I forgot the whatever. I'll just redraw him. And secant squared is also equal to um cos squared theta. That's what it also equals to. So I'm just gonna put them here. I don't know if that's needed. Well, remember it equals to 0. Yeah. So I think there's two ways you could do this. You could like do like um you could do like common denominator, but that looks kind of annoying. So I'm just gonna put that on the other side. So x equals to cos squared theta. Hold up. Someone looks sketch, bro. Did I lose a VO term? I did. Sorry. Almost messed it up. I was like, wait, where did the velocity term go? Because I know you need it for the final equation. I was super weirded out. Yeah. Okay. Tan theta all over VO squared cos squared theta. Now, if we move this to the other side, right, it's gonna. So. Oh, wait. We don't need to move that to. We want to move it here because we want to isolate tan. Oh my god. See, this is what happens when you just wing your videos. You make a lot of mistakes. Yeah. But honestly, I like winging my videos because it's a lot more fun. It's like unscripted videos are just really like genuine, right? In my opinion. Like I like it when people do unscripted videos because you actually get to understand them more as a person, you know? It feels like more real, not just like AI slop. Yeah. So this cancels gx squared tan theta. And basically what we do here, x VO squared all over g x squared equals to tan theta, and then we just do what x, but no, that cancels. VO squared all over gx. Yeah, that's our final answer. It wants us to find tan, pretty sure. Yeah, it wants us to find tangent. So yeah, that is our answer. Boom. And essentially, why the maximum height wouldn't work here? Because when I first did this problem, I was like, wait, I can just do max height formula, and then just do opposite of adjacent because that's definitely a tan. No, that doesn't work out. Why? Because like it depends on x. Like you could like shoot it at like 89.9 degrees and have it go like really high, but it but if x is but that only works if x is really small, right? And have it like it only works if x is really small, but if x is really large, it won't even hit the wall. So that's why this formula is important. Hope that cleared up some things. Yeah, so if you have any comments, you can, well, if you have any questions, just leave them in the comments. The calculus is pretty heavy this time, but yeah. So yeah, hope to see you guys next video. Yay!